In Lesson 8, we're going to talk about how to divide polynomials, and we're going to learn a new method of dividing polynomials that's called synthetic division. So in the last lesson, we talked about how to divide polynomials using long division, and with long division, you can divide by any type of polynomial that you want. It can have any number of terms, it can have any degree or any exponent, so like you could divide by something like 3x squared plus 2x minus 5. However, in this lesson, we're focusing on synthetic division, and it only works when you're dividing a polynomial by a linear binomial, meaning linear meaning it just has an x in it, so no squared, no cubed, it just has an x, meaning the exponent is 1, and binomial meaning it only has 2 terms. So the restrictions here for synthetic division is that you can only divide a polynomial by a linear binomial, and the coefficient of this linear binomial has to also be 1. So the leading coefficient, or the number in front of x, has to be a 1. You're going to find that it's easier, so that's why I'm going to show it to you. However, the downfall is it only works when you are dividing by these linear binomials. So examples of linear binomials are things like x plus 3, x minus 5, x minus 2, x minus 50, any type of binomial that it's a linear exponent of 1. So when we do synthetic division, it's actually going to look a little bit different than long division, where we're going to use this like kind of a chart here to organize it. And how we set it up is we only look at the numbers or the coefficients. We don't look at any variables, and then we'll just end up putting our variables back in to figure out our final answer. So whatever I'm starting with, so in this case I have this piece here, I'm going to write all of the coefficients of those terms down in this chart. Now you have to make sure that a couple of things. Your polynomial that you're starting with is in standard form, meaning the exponents are in decreasing order, and also that you have all of your terms. So since the highest term is an x to the fourth, that means I need to include x to the fourth, x to the third, x squared, x, and then the number. So if you notice, I'm missing an x squared term. So what that means is when I write my coefficients, I'm just going to put a 0 in there as like a placeholder since I'm missing the x squared term. So I look at my coefficients of x to the fourth, it's 1. Then I go to the coefficient of x to the third, which is 8. And again, that 0 is going to be my placeholder for the x squared, since there's no x squared in there. -2 is going to be the placeholder for the x, or the coefficient for the x, and then -23 at the end. And I'm dividing by x plus 8, which means that I'm always going to use the solution to this, or the 0 for this, which if this is the factor x plus 8, the solution, or the 0, is the opposite sign. So I'm going to put a -8 here as what I'm dividing by. So you always do opposite sign. So I'm just going to make a note of that, opposite sign. So what the process is now is that you're always going to carry this first term down. So you're just going to bring the 1 down. And then you're going to multiply that by this -8. So 1 times -8 gives me -8. And then I'm going to add these vertically. So 8 plus -8 is 0. And then I'm going to multiply the 0 times -8. I get 0. Then I'm going to add vertically. So I get 0 again. 0 times -8 is 0. Add that with -2. We get -2. -2 times 8 is -16. Add that with -23. We get -7. And now I'm done because I've done all of the numbers vertically. So a couple of things to make note of here before we come up with what's our answer is that I always multiply diagonally. So I carry down that first term. So the first thing you do is carry down the first term. Second thing that you do is you multiply diagonally, and you always are going to multiply diagonally. So all of the numbers, I multiplied them by 8, and then whatever I got out, I put in the next column, and then I added vertically. So you add the numbers that are vertical to each other. So add vertically. So that's kind of the process. This final answer, how to interpret it, this number here is always the remainder. That's how much is left over. So this is the remainder. So then my answer, you always are going to start with a degree less than what you divided, that you started with, because if you look, I took an x to the fourth polynomial and I divided it by an x, so I should always have one less degree. So that really means that this is going to be an x to the third term. This would be an x squared term, an x term, and then here's my number. So I'm also going to write that. So to write the answer, start with 1 degree less than the original. So the original polynomial. So since I started with an x to the fourth, this is really going to be, my leading coefficient is going to be 1. So I'm just going to write it just so you can see where it's coming from. I started with an x to the fourth and I divided by a linear term, which means now I have an x to the third plus 0 times x squared plus 0 times x, and then minus 2, and then the remainder is going to be negative 7. So that means to write this as your final answer, you don't really need these coefficients here, so it's just going to be x to the third. These are just going to be 0, so I'm not going to worry about those. Minus 2, and then when we write the remainder, we always write whatever we divided by. So it's going to be remainder negative 7 over whatever we divided by. And we divided by x plus 8, so it's going to be over x plus 8. So this is my final answer to the problem. Okay, so we'll look at some other ones too so that you get familiar with the process, but overall the process I think is much quicker. At first it seems weird because it's different, but then it's much quicker. So let's look at some other examples. So this example here, we're going to use synthetic division. Again, I can use synthetic division because I'm dividing by a linear term. So I start with writing out all of the coefficients of my polynomial, and it looks as if I have x to the fourth is the highest. All of my terms are written in standard form, so I'm just going to go ahead and write the coefficients. So I have 1, negative 8, 12, negative 11, and notice I don't have a constant term, so I'm going to put in a placeholder of 0 in there. And then we take, this is what I'm dividing by, so that's going to come out in front, and it's going to be the opposite sign. It's going to be a plus 1. So we start by carrying down the first term, we get 1, and then we're going to multiply. 1 times 1 is going to give me 1, so that goes in the next spot. Then we add vertically, so I have negative 7. Negative 7 times 1 is going to give me negative 7. 12 minus 7 gives me 5, or 12 plus negative 7, same idea. 5 times 1 gives me 5. Negative 11 plus 5 is going to give me negative 6. Multiply again diagonally, so negative 6 times 1 gives me negative 6. Add, we get 0 plus negative 6 gives me negative 6. So my remainder is this negative 6. My answer is always one less than what I started with. I started with an x to the 4th, so that means my answer is going to be a 1x to the 3rd minus 7x squared plus 5x minus 6. So I'm just taking these numbers up top here, and I'm just rewriting them as coefficients in decreasing order. And then I have my remainder as minus 6, and it's over whatever I divided by, x minus 1. So there's my answer. Okay, so let's look at some more examples. So same idea, the setup's just a little bit different, where it's given to us as a fraction, but you're going to start off the same way. Make your organizer. This is what you're dividing by, so that's going to go out in front with the opposite sign. And I'm going to write all of my coefficients. So x to the 4th is 1. Notice I'm missing an x to the 3rd, so it's going to be a 0. And it's going to be minus 10, minus 2, and 4. Start by carrying down the 1. And we're going to multiply negative 3 times 1. So we get negative 3. Then we're adding vertically. So 0 plus negative 3 is negative 3. Multiply, we get 9. Negative 3 times negative 3. Add vertically. So negative 10 plus 9 is negative 1. Multiply diagonally. Negative 3 times negative 1, positive 3. Add vertically. So we have 1. 1 times negative 3 is negative 3. And add those vertically, we have a 1. So my remainder is 1. I started with a degree 4 polynomial, so x to the 4th, which means my answer has to be in degree 3. So 1 times x to the 3rd is the first term, minus 3x squared is the next one, minus 1x, I just forgot the 1, minus, I don't need to worry about the 1, and then plus 1 at the end, plus my remainder over whatever I divided by. So I divided by an x plus 3. So there's my answer. So you can see that this is much quicker. It's just an unusual process. So we have just a couple more, so 2 more. So this one here, if you notice my polynomial, it is not in standard form. So that means I need to rewrite this so that it's in standard form first. So I'm going to put my x to the 3rd minus 12x squared plus 39x minus 29. And that whole thing is going to be divided by x minus 4. So I put it in standard form, so that way when I go to my graphic organizer here, I have 1, negative 12, 39, negative 29. I don't need to insert any zeros because I start with a degree 3 and I have all of the terms in decreasing order. So then I have this term here is going to come out in front with the opposite sign. I'm going to carry down the 1, multiply, add vertically, so I get negative 8. Multiply 4 and negative 8, we get negative 32. Add them vertically, we get 7. 7 times 4 gives me 28. So your remainder is going to be negative 1. So your answer, since we started with a degree 3, is going to be 1 less. So it's going to be x squared minus 8x plus 7 with a remainder of 1. So remainder over whatever we divided by, which was x minus 4. So then our last example here is we have a polynomial divided by negative 10 plus x. So if you notice, this term down here is written differently than the previous examples that you've seen. But basically, negative 10 plus x is the same thing as x minus 10. So we're still dividing by a linear binomial. It's just formatted a little bit differently. So when I go to set up my synthetic division, again, I'm going to make sure that the first term, or the first polynomial that I'm dividing by, have to make sure that's in standard form, and it is, and all of my leading coefficients are there. So I have 4 for the first leading coefficient, negative 44 for the second coefficient, 47, and then negative 63. We don't need to put any zeros in there because this is in decreasing order and all of my terms are there. And the x minus 10, opposite sign, so it's going to be 10 on the outside here. And then we bring down the 4, multiply 4 times 10 gives me 40. And we're adding. Negative 44 plus 40 is going to give me negative 4. And then again, multiply negative 4 times 10 is going to give me negative 40. You're going to add 47 plus negative 40, which is like 47 minus 40, so we get 7. 7 times 10 is going to give me 70. And then you're going to add these, so we're going to get 7. So my remainder will be 7. So my final answer then, so the final answer is going to be always 1 less than what we started with, or 1 degree less. So we started with an x to the third. So my answer here is going to start with an x squared. So it'll be 4x squared minus 4x plus 7 with a remainder of 7. So it's going to be 7 over whatever we divided by, which is x minus 10. Or you could put negative 10 plus x, doesn't make a difference. So there's the final answer, and that's it for synthetic division. So remember, synthetic division only works when you're dividing by a linear binomial, where long division will always work.